Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the extraction, properties, and uses of zinc and chromium. In our last lesson, we learned about the extraction, properties, and uses of tin and lead. We also learned how tin and lead react with different substances, and we discussed some of the uses for each of these metals. In today's lesson, we are going to describe the processes used to extract zinc and chromium from ore. We will explain the chemical properties of each of these metals, and we will describe some of the uses for each. Let us begin. Zinc, which is often referred to as spelter, is the 24th most abundant element in the Earth's crust. Like tin and lead, zinc has only one important ore from which it is extracted: Zinc Blende. Zinc Blende is concentrated using froth flotation. It is then roasted in air to produce zinc oxide and sulfur dioxide. The sulfur dioxide is used to make sulfuric acid. Zinc is extracted from the zinc oxide. This can be done using two different processes. In the first process, zinc oxide is reduced by carbon monoxide at 1,200 degrees Celsius. In the second process, zinc blende is heated in air at a low temperature. This produces zinc oxide and zinc sulfate, which are both dissolved in sulfuric acid. Zinc dust is added to precipitate cadmium, and then the zinc sulfate solution is electrolyzed to produce pure zinc. Zinc is a silvery-colored solid metal. It tarnishes very quickly when it comes into contact with moist air. Zinc dissolves in dilute hydrochloric acid, setting hydrogen gas free in the process. Zinc also reacts with aqueous solutions of sodium hydroxide. The reaction produces sodium zincate, which means that zinc displays amphoteric properties. When zinc is heated, it reacts with oxygen to form zinc oxide. Large amounts of zinc are used to make alloys. Some common alloys made with zinc include brass, which is an alloy of copper and zinc. Leclanché cells, mercury cells, and alkaline manganese cells are also produced using zinc. Zinc acts as the negative electrode, or anode, in these dry batteries. Zinc can also be used as pigment in white paint. Zinc is often used to coat iron. What would be the purpose of this, and how would this process be done?
Students, let's get ready. Begin. Time's up. let's get back to our lesson.
Welcome back, students. Zinc is used regularly to coat iron because it prevents the iron from rusting. If that was part of your answer, great job. Let us discuss how this process is done. A thin coating of zinc can be applied to iron using electrolysis. A thicker layer can be applied by dipping iron into molten zinc. Students, it is also important to note that zinc is an essential mineral for humans. A deficiency of zinc in your diet can cause a variety of health problems. This is an issue facing developing nations. Let us move on and discuss chromium. Chromium is a silvery metallic element that is the 21st most abundant metal in the Earth's crust. It is primarily extracted from the ore chromite. Chromium is produced into two different forms: ferrochrome, which is mainly an alloy of chromium and iron, and pure chromium metal. Ferrochrome is produced by reducing chromite with carbon. Manufacturing pure chrome has 4 basic steps. Chromite is fused with sodium hydroxide in air, and chromium-3 is oxidized to chromium-6. Ferric oxide cannot dissolve in water, but sodium chromate can. Therefore, the sodium chromate is separated from ferric oxide by dissolving it with water. The two are separated by decantation or filtration. The sodium chromate solution is acidified to convert it into a less soluble sodium dichromate. Then, sodium dichromate is reduced to chromium-3 oxide by heating it with carbon. And finally, the chromium-3 oxide is reduced to chromium by aluminium. Let us move on and discuss some of the chemical properties of chromium. Chromium is protected from corrosion by a very thin, transparent oxide film. Concentrated nitric acid and other oxidizing agents build up the oxide film to the point where chromium eventually becomes passive, which means that it no longer dissolves in the acid solution. Chromium dissolves in hydrochloric acid and dilute sulfuric acid to form blue chromium-2 ions. These ions are only stable if there is no air present. This unstable chromium-2 state is easily oxidized to the chromium-3 state. Traces of oxygen are removed by bubbling the gas through a solution containing chromium-2 ions. What are some of the uses of chromium? An alloy of chromium and nickel is used to make nichrome wire. This wire is often used in chemistry labs. Ferrochrome, which we already discussed, is used to produce stainless steel. Stainless steel is used for all sorts of things, such as kitchenware, appliances, and tools. Chromium is also used to electroplate other metals. This process provides a shiny, corrosion-resistant surface. Students, what is electroplating? Pick the most correct answer.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. If you picked answer C, then you are correct. Great job. In today's lesson, we learned about the manufacturing processes of zinc and chromium. We also learned about some of their chemical properties and some of their uses. This brings us to the end of our lesson. Until next time, thank you, teacher. Thank you, students.